Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm going to do the image resampling example once again. But I'll do it slightly differently and probably much more interesting than before. So let's just get started. Let's see, black dog resample. So the idea is to have an image and then to do some kind of resampling, whether using Python script or using the displacement modifier, and then kind of transfer all the data and pass it into something, something else. So let's import, let's go to compositing first, and then in Sverchok, let's scatter some points with, let's use a random vector and viewer. Let's use viewer B mesh right away instead of using the viewer. And let's plug this in, and then you can see in the 3D scenes we already have some dots, top view. The random vector is actually kind of 3D, but for what we are doing we can make it kind of like a 2D. So in order to do that, we just need to use the new rewire, vector rewire, and then we can use the scalar mode. So we can see if we are putting the scalar, pipe it into the Z with the scalar being 0, we are basically flatten that object. This can be useful for many reasons. And what's the next thing to do? This scatter is kind of okay, but in order to make it more even in space, you can use vector randomize input vertices as well, and just randomize it in all directions like that. So we have scattered points. We have only 200. Let's make it 1,000. At some point we're gonna try to make it 100,000, but for now just 1,000. So we have some scattered points in 3D scene, and I will use my technique simply using the displace modifier. Displace modifier, because this guy is kind of like a mesh, we can displace it and then create a texture, and then this guy is gonna be our image. I will be using probably the black dog image. This guy is not actually squares, but so it might be a little bit squeezed. But I'll use my technique where I have a plane here, kind of scale it in the proportion of the image, so the image is not squeezed anymore. And using this guy as reference, I need to turn it into wire so we don't see it in 3D. And then also I will never render this guy. So with this guy selected, using the image, we're gonna use the objects as our kind of a UV space placement. A more correct way to do this is probably to use Python and kind of sourcing the UV of the image. But for now, this is kind of okay. I'll have more points for now and then kind of try to figure out the face of the dog. Okay, it looks like, okay, this is kind of okay. You can see kind of the silhouette of the dog. So we have like 5,000 points now. That's okay. I think Sverchok and Blender can handle it. So the idea here is really to use these points and then kind of instance some like bunch of polygons. We need to do it really carefully. Make sure, let's see, we have merge here for the alpha, and we want to use the points to generate some polygons. Let me check. Okay, let's deal with the displacement first of all. Let's get rid of the mid level and then make sure we are using RGB to XYZ. Yeah, I guess that will do. So this is actually, this setup is just resampling the image. Okay, the image RGB for every point at that position in 3D space. The next thing we want to do is to get this point back. Object, get this guy from the 3D scenes with a pause on, one with pause on, one with pause off, and then using a vector math, kind of do the subtraction sub. So this guy minus this guy equal the RGB. This is the RGB for each point. Okay, that's being sampled. Although we cannot do some kind of averaging, we are only like doing a point sampling. I wish I can do like 3x3 or 5x5 point sampling. But anyway, we're gonna use the points to generate some polygons. Okay, so I'm gonna use a circle, and a circle with a vertices, 3 vertices, so it's become a triangle. And I'm going to use another B-mesh viewer, and with the merge on, and use these points into the matrix, and this guy plug into the vertices and the polygon. Okay, so we should get our instance object, all these triangles, and all we need to do is just to give this guy color. We are working in cycles, so I'm gonna give it a material. It's called SV material, and this guy, I switch to the materials, and then I will also give it a Vertex Color. So color, Vertex Color new. We colorize the face. Currently we only have single face for each of these objects, so that should be good for us. Give it a color, and the color should be coming from this guy. If everything works as planned, we should get the color of the dog for every triangles. So get back to this guy, and then attribute, use the Sverchok color. This is the attributes that's been assigned to these objects. You see this guy, SV call, plug into this guy and switch material, and we should be getting the dogs. Okay, seems to be it's there. We can hide these points and just look at the dogs. View, top view. This is 5000 sampling, and let's go back to our setup. I think this is almost good, except for one thing. Currently all the triangles are in one spot, so they're overlapping with each other. They're not like points where it's okay to overlap. They are not okay to overlap, so you need to be careful there. Here, and use range float, and depending on how many, so we have 5000, right? So integer, this is the count. This is 5000. I'll increase the limit to 10,000. So we have 5000. Plug into this guy, and we want 5000 into this number, and we're gonna step up every 0.01, plug into the scalar. So what's happening is the points kind of being pushed up. Maybe currently it's too much, but that's the idea. Oh, that's too small. 0.0001. Okay, view top. That should be okay, and then we can increase the radius of this triangle. Oh, okay, see, you can see now the triangles, each one have a color from the image. It's sampling the color of the image. And this guy is actually in 3D. Currently the triangle is all facing the same directions. Maybe you want to randomize that as well. So for that we can use the matrix in properly. So this is the location for each point, or it's and then the rotation we can randomize. Random vector for the rotation. How many is from this guy? Plug into that guy. We have random rotation now. Plug into this guy. We can actually just plug this into the angle, I think, and the matrix will take care of everything. Okay, so we are pretty much almost like turning this into like a particle simulations, basically. Still, it's gonna perform really quite fast. I have not tried 100,000, but this seems to be pretty good. I'll make this a bit smaller, and then I'll increase the number of points to maybe 10,000. You can try 100,000 or 1 million, but this seems to be pretty good value, and it needs to do the resampling, and done. That's probably too small. 0.06, and we have this. It's almost like a volumetric. It's basically like a particles. It's only like 5,000. It's very low value. Maybe you can try. Oh, this actually okay. 10,000, 100,000, maybe even slower. But I like doing it like this instead of using current particles. To be able to use both is actually better if we have like particle nodes, and I think you can actually do this kind of thing using particles and kind of map the particle UV into each particles, and then do it more. But this is interesting because you can perhaps want to randomize the position. You can do it using nodes. Like that, we're kind of scattering every point, but keeping this guy is still keeping the triangles, remember? So I can scatter it further. It's gonna be like all over the place, and then we cannot tell the image anymore. It's kind of like blurring the image, but we can always zero this out, animate it slowly until it goes back, and recreate the image like that. Okay, so that's pretty much it for this setup. It's rather simple, but basically this guy is doing the sampling. This guy bring the color back from the displacement trick that we did, and then this guy will generate a circle or a triangles in this case for every point, and then assigning it to the vertex color of every vertices. Cool. So that's pretty much it for this live noding. If you have any questions, suggestion, feedback, just let me know down below. Thanks again for tuning in, and I'll see you in the next video. Bye.